So the next talk, the second one of this morning session, will be given by Dr. Joe Fong of NSPO. And he's a senior engineer at the NSPO, been working on the CubeSat program. So he's going to tell us, the title is, I think, the past and future of CubeSat.
Sorry, I put a few Chinese character on my screen because I think this is more popular science and educational, and not just there's also outside people that may interest in my talk, and so I put some Chinese font under some slides. Okay, my presentation is past, present, and the future of CubeSat in Taiwan. I've been taught this one in Chinese in the last year during the Taiwan Science Union workshop, second workshop. I try to put more, especially the recent launch of our two CubeSat that was on the Transporter 1, and show some initial results. Okay, this is my outline, introduction, CubeSat history and the world trend, and then talk about the past and present of CubeSat in Taiwan. And for the present CubeSat that we founded, that there are two, was launched on the Transporter 1. I show some initial results. And last, I talk about the future of Taiwan CubeSats and conclusions. As I said, I not just talk. Last year, for promotion-wise, we put a series of articles on the Science Monthly magazine, October issue of last year, and you could see my article in that series of magazine. And below, I shows the link, so that everyone could get it. I think it is free. Most of people now know what is a CubeSat. However, I just want to say it again, that a CubeSat is a cubic shape of a miniature satellite. It's 10 centimeter by 10 centimeter by 10 centimeter, roughly the size of a Rubik's cube, and weighing about 1.3 kilogram. And the CubeSat can be used alone as a one unit or in groups of multiple units, maximum 27 units. And the advantages is you could build it very rapidly within 2 years. And you could purchase a commercial off-the-shelf components, so it become a simple technology as compared to the traditional big satellite technologies. Because it's small, so it's simple to design, and there is actually no space debris issues. It will burn up in the atmosphere upon the re-entry. And of course, it's a low cost, etc. And some CubeSats actually have become the first ever satellite of a country, and being launched by universities, state owner, or private companies. Here shows some of the satellite mass classifications, and the CubeSat actually fall into the microsat, nanosat, or picosat. And the data coming from the nanosat database, you could get many figure charts, informations there. And the CubeSat become hot because there is a full wave to make it become so popular now. Since the 2003, the first CubeSat launch, and I call it the Wave 1. The first wave is aerospace, defense, and educational project that try to invest on the first CubeSat. And the second web is the National Science Foundation of the US that performs some scientific researches. And third web is NASA, ESA that spend not much money, but to use the CubeSat as a technology demonstration. And the web 4 is the new space 2.0, the commercial age that is coming. From the link, you could see the NASA that shows lots of small sat and CubeSat fleet that is operating past and the future mission. So it's just not a few, it's huge. And for individual mission, you could go to the link database and know more detail about each mission. And not just NASA, ESA also treat CubeSat as technology demonstrations. So there's a link I show above that you could go to see whatever CubeSat mission you are interested to perform. CubeSat, that's 1,300 CubeSat launched. There's even 2 interplanetary CubeSats was launched, performed interplanetary missions. Also, the most nanosat on a rocket as of January 1st is 103. But after the transporter 1, I think we could set is 133. That's countries with nanosat as 70 countries, and in the database that shows almost 500 companies there. And it also forecasts there's another 2,500 nanosat to launch in the next 6 years. And here shows more during the database. Then not just shows the launches statistics, but the launches with forecast, constellation missions, the world map, the CubeSat type about the size, and the CubeSat launch in the which orbits. And so also there's a statistics talking about the nations and continents and the current status and the frequencies and bands they use, and by type, by institution, and by organizations. And also commercial companies funded profile, and also by launchers, by deployers, and currently total numbers. So lots of information there. CubeSat, actually, rise of CubeSat is one of the top 10 breakthrough of the year in 2014 from Science magazine. Also in the same year, from Nature magazine, this article also says that the mini satellite, actually CubeSat, proved layer scientific power. I like this article very much because the committee chair, Thomas Zerbenchen, now is become as associate administrator of NASA after he present this presentation. And the article is free, is called Achieving Science with CubeSat and Thinking Inside the Box. The idea is, in the article, they prove that the CubeSat is a disruptive innovation. And the idea actually comes from the Clayton Christensen in 1995, that he introduced the idea of a disruptive innovation. and distinguish it from sustaining innovation, and defined it as the process by which a product or service takes root initially in simple application at the bottom of a market and then relentlessly move up market, eventually displacing the established competitors. My honor that I have a chance been attending the SmallSat conference for 3 or 4 times, and I have a chance to photo with these 2 CubeSat fathers. And we know that in 1999, the first CubeSat concept was developed by the professors Bob Pitt from Stanford University then, and also from Jody Buksari from the California Polytechnic State University. And they think that the CubeSat could provide students with an affordable hands-on experience in space explorations. I also had the honor to photo with my colleague, and of course, I call it a father of Taiwan CubeSat, Professor Joe Zhuang. By the time in early 2001, we started a YoungSat program, and the YoungSat program actually, the origin came from a series of lectures called Spacecraft System Design, given by Professor Joe Zhuang, held in the National Center for High Performance Computing NAME. And besides the Bravo model and the engineering testbed, the proof of the operation concept, we actually then built 3 YoungSats, 1A, 1B, and 1C, instead of 1, and was manufactured with slightly different configuration and purposes. By the way, Dr. Albert Lin is the YoungSat project manager. CubeSat followed the open source. Open source actually become an important trend in the development of a global CubeSat. There is a project called LibreCube. It's the first CubeSat open source project. It was established by the other schools, a student of Taiwan's CubeSat father, Professor Dr. Joe Zhuang. And if you Google this website, most of the design, almost 1/2 of the information of the PACE CubeSat built by the National Chen-Joe University is open to the public in open source way on this website. Also, there is ground station wise, there's also open source. The SecNode GS is the first startup company to open source the CubeSat ground station. The website teaches the public how to make do-it-yourself a ground station in the open source way and connect them in series to form a ground network in open source. I would like to take this opportunity to thank this website, because they actually collecting our CubeSat since it launched last month, and they provide lots of valuable information there. The last bullet is addressed the Libre Space Foundation, which actually also publishes open source technologies for space engineering on its website, and allowing anyone to participate in the design and the manufacture of the satellites. I also, I think that is in the 2016, I write articles that launching the Taiwanese CubeSat. I'm sorry, it's in Chinese. to promote that, encourage Taiwan industry have more people to involve, to invest and fund it, and launch our Taiwan CubeSat. For the present, in order to build a sustainable Taiwanese space industry, there is a Taiwan Space Industry Development Initiative called a Micro Satellite Development Program. In this program, that including the CubeSat project that was executed by NSPO. And the purpose for this CubeSat project is to cultivate new generation talents for space technologies and to generate CubeSat commercial products. And this CubeSat project has started since 2017 and aim to launch 3 CubeSats in 2020, actually 2021 now. And the planned orbit is a circular with altitude within the 450 to 600 kilometers. And this CubeSat was contract, CubeSat contract, and their launch service contract was performed by university and the domestic companies in Taiwan. ESAT also named Yishan is a J Mountain, and they are the 2 communication payloads on this ESAT CubeSat. One is an automatic identification system, we call it AIS receiver, and automatic packet reporting system, APRS receiver, and aiming for dynamic monitoring of ships and the vehicles, business operations, traffic control, and emergency rescue, homeland security, and other purposes. And the AIS receiver can receive AIS packets from vessels globally, and AIS packets can be stored on board and then dumped to ground station via the UHF frequencies. And it will improve the maritime navigation safety. The APIs receiver can receive APIs message from cars for traffic monitoring and from the ground sensor device for large area environmental monitoring. NORSAT will be launched in the middle of this year, and the payload for NORSAT is an automatic dependent surveillance broadcast with called ADS-B receiver. And the technology and devices of ADS-B has been used on commercial airplane for many years, while using the satellite to track airplane has the benefit for global coverages. IdeaSat, we know that also named the Flying Squirrel. The science payload for IdeaSat is the compact ionosphere probe, an all-in-one in-situ plasma sensor developed at the National Central University, based on the heritage from the advanced ionosphere the probe aboard the Formosa 5. And its mission is to observe the ionosphere and verify the satellite altitude control technologies. The CIP will be capable of monitoring the thermodynamic structure of the ionosphere. We also identify plasma irregularities that can disrupt the satellite and terrestrial radio frequencies through the space. More presentation will be given by Dr. Rowan after me. This chart shows the Falcon 9 Transporter 1 flyer that Transporter 1, we know that is a multiple dedicated ride-share mission, and it was launched in January 24 last year. And there's a payload list, but based on my knowledge, the payload list actually needs to be updated. And USAT and IdeaSat was one of the two payloads. And here shows a photo took by Ben Cooper from Twitter, that where the two CubeSats are allocated on the satellite Christmas tree. Based on the SpaceX information, they are totally one of the 43 satellites on a single rocket, and the link JSR report 789 that actually showed much detail of the individual satellite and when they were launched, and here shows the statistics of the countries, and Taiwan actually provide two satellites on this single rocket. And most of the satellites are operating in a synchronous orbit at an altitude of 525. And ESA and IdeaSat were successfully separated at the launch plus 59 minutes. And then below that shows the other communication information in case you want to receiving the ESAT and IdeaSat signals to get QSL car. Here shows a video of the three CubeSats. Okay, here I show a few of the early orbital results. International-wise, we received lots of hands, especially Mike from Germany, and Daniel from Spain, and Sato-san information from the SAT-NOGS networks. That after the January 24th launch in January 25th, Mike actually provides the ESAT spectrum and also the IdeaSat spectrum. And Mike later, based on the information provided by NCU that shows the satellite telemetry on his website. And Sato-san also post his decoded ESET informations on his Facebook that based on the information we provide. And domestically, we receive in the 4 days later from the Zhang Kunliang 老师 and also Cai Yaobin 老师 and of course and also Huang Wenjie and also our ground station that received ESET signals. And they could also receive the idea set and able to decode it. However, for the ESET, the satellite is the small, 2 kilogram. I think it's the ever launched in Taiwan. So small CubeSat, and the signal is such weak. And even though we model our ground stations, the signal decoded is still not well. We will present more in the coming future. And as of 26th of February instead of January. The ESET data still shows good health with the top low frequency SIP on the SAT or Node.js network. I mentioned only a few Cubesat, but actually there's lots of Taiwan-made Cubesat. As an iCharts, I provide a table in Chinese in the magazine, and I also provide here. And the last 2 columns shows the ESET 1 and the NASAT. And next slide, the first column, the second 2 shows the idea set. And they are more, CubeSat was actually developed and still to be updated. Okay, go to the last portion. I want to suggest some for the Taiwan CubeSat from commercial or engineering point of view, basically from me. NASA has been planning for low Earth orbit commercialization to achieve a robust LEO economy, and it's become a trend that the new space 2.0 that is there. The arrow is there, and Taiwan needs to take advantage and step in to this new industry. And second is the open source has become an important trend in the development of a global CubeSat. And CubeSat is disrupting the space industry from various fields with disruptive innovations. And Taiwan needs to develop every element of the CubeSat ecosystem. It must not only focus on the early foundry and the mass production development, as was happened in the personal computer era. And Taiwan's past successful development models and experience in the semiconductor and also information and the communication technology ICT industries can be used in the coming personal satellite industry. Coupled with the public-private partnership to accelerate the improvement of suitability of technology readiness level of core technology developed in Taiwan. below I showed the link where this CubeSat ecosystem the child coming from. And Taiwan actually could take any element of this CubeSat ecosystem from the funding source, from the owner operator, and from the hardware provider, and also from a service provider perspective. And to increase the mission success rate, we should adopt a fry, learn, refry approach. This approach says that instead of just build one fry models, but to build two fry models. And the second model could be soon modified and launched if issues was arise during the first flight models. In addition, that Taiwan can make a use of the successful experience in the development of the Formosa series of satellite missions in the past, and develop the scientific missions of a miniature-sized CubeSat. For example, Formosa 2, 5, and 8, we actually could build optical remote sensing CubeSat missions. And for Formosa 3 and 7, Trident mission, we actually could build GNSSR CubeSat missions. From communication point of view, the future low Earth orbit communication satellite will be the commercial space industry with the largest output value. And the relevant key technologies can be verified by using the CubeSat, especially the inter-satellite link, microwave or optical communication, and also the space laser communication technologies. And from my observations, many professors in university also have proposed lots of propulsion technologies. And we actually could use this propulsion technology on the CubeSat for orbit maintenance, especially for very low Earth orbit satellite, which I think is also very suitable for development in Taiwan. I think this is my conclusions also. And this is my last slide. Let's launch Taiwan into the higher orbits and beyond. And thanks for your attention.
Joe, thank you so much for this presentation.